Hey guys, today we're going to talk a little bit about similarity and transformations, and specifically we're going to talk about dilations. Okay? And a dilation with scale factor k is greater than 0 and center 0, 0 maps xy to kx, ky. Now that's a bunch of gibberish, but what that's basically saying is that if you had an ordered pair, something like 1, 2, and it said it wanted you to dilate it by a factor of 5. Okay, so our dilation is 5. All that's saying is that you have to multiply your x value and your y value by 5. So 1 times 5 would be 5, and 2 times 5 would be 10. Okay, so if you dilated 1, 2 by a factor of 5, that would give you the new ordered pair 5, 10. Okay, and likewise, if you happen to have the ordered pair 10, 5, and we wanted to dilate by a factor of 1/5, all it's wanting you to do is take 1/5 of the value of each x and y coordinate, and that would give you your new dilated ordered pair. So 10 divided by 5 would give us 2, and 5 divided by 5 would give us 1. Okay, so the dilated ordered pair of 10, 5 would give us 2, 1. Okay? All right. So another little thing that you need to consider is dilation with scale factor k and center of 0, 0. xy goes to kx, ky, and k is greater than 0. And it's basically saying the same thing, basically just telling you how to dilate. It's a general formula for you. All right. Okay, now it says, apply the dilation to the polygon with the given vertices and describe the dilation. Okay, so let's look at example number 1 here. All right, so on this one it says that D goes from xy to 3x, 3y. So all that's saying is that we need to take A, B, and C and multiply the x by 3 and the y by 3, and that will give us A prime, B prime, and C prime. So let's take our 1, 1 and multiply each by 3. So 1 times 1 is 3, and 1 times 3 is 3. So our new ordered pair would be 3, 3 for A prime. Okay. For B prime, you have 3 times 3, which is 9, and 1 times 3, which is 3. Okay, so 9, 3 would be our B prime after we ran it through our dilation scale factor. Okay, and lastly, 3, 2, 3 times 3 is 9, and 2 times 3 is 6. So that would be our C prime. Okay, so if we wanted to describe the dilation going on, we would simply say it's a dilation with scale factor of 3. Dilation with scale factor of 3 centered at 0, 0. Okay, so all we did was multiply each your x and your y by 3, and we can see plainly that it's a dilation with a scale factor of 3. Okay, let's try another one. Hey, this time it says that we're going from x, y, and we're having 3/4 of the amount of x and y, so we're dilating and making it a little bit smaller this time. Okay, so let's start with our first ordered pair, negative 8, 4. Basically, you need to tell yourself, what is 3/4 of negative 8? Well, we know that 3/4 of negative 8 would give us negative 6, and 3/4 of 4 would give us 3. Okay, so this would be P prime after we put it through the scale factor there. Okay, so let's try Q here. Let's ask ourselves, what's 3/4 of negative 4? 3/4 of negative 4 would give us negative 3, and 3/4 of 8 would give us 6. So this is our Q prime. And lastly, 3/4 of 4 would give us 3, and 3/4 of 4 would give us 3. So that is R prime. And you can see that if you look at all your ordered pairs for your red points, all of those appear for the prime ordered pairs that we found. Okay, so if we wanted to describe this thing, we would say it's a dilation with scale factor of 3/4 centered at 0, 0. Okay, so here's just a few examples of how you would filter through a dilation scale factor and figure out your prime ordered pairs. Okay, so let's move down here a little bit. Okay, and it says, determine whether the polygons with the given vertices are similar. And there are two things that you need to do to decide if they're similar. One, you need to decide if the angles are congruent. Well, since we know that both of these are rectangles, we know that the angles are congruent. Okay, so our number one, we're in good shape here. Okay, the second thing, you need to see if the corresponding ordered pairs have similar ratios. Okay, so if you look at this, A would go with J, B would go with H, D would go with L, and C would go with K. So if we look at J going to A, what's happening to all of your x values? Well, you know to go from -2 to -6, you have to get 3 times larger. So to get from -2 to -6, you're 3 times larger, and to get from 1 to 3, you're 3 times larger. So your scale factor on both sides is going to be 3/1. Okay? What about from C to K? Okay, to get from C to K, you can see that 1 has to get 3 times larger to get to C, and 1 has to get 3 times larger to get to the y value of C. So both of them you have to get 3 times larger, so again, your scale factor is 3/1. Okay? And if you look at B and H and D and L, you're going to see the same thing. Okay, so if you compared the large one to the small one, to get from A, B, C, D to J, H, L, K, you're going to have to get 1/3 smaller. Okay, so to go from X, Y, your scale factor is 1/3 X, 1/3 Y. Okay, so all that's saying is that basically the small one on the inside is 1/3 the size of the big one on the outside. Okay, so these in fact are similar rectangles. Okay, so make sure you have that down, and we'll look at the next page. All right, let's look at one more. Let's look at number 5. It says determine whether the polygons with the given vertices are similar, ABC to DEF. Okay, so basically we're having to get from blue triangle to blue triangle, but first we have to see what the pattern is to get from ABC to ABC prime. Okay, so each time, what are you having to do to get from one to the next? Well, you can see that to get from A to A prime, you have to go 1 in the x direction, and then we have to go down 5 in the y direction. Okay, so to make the pattern, we know that triangle ABC is translated to triangle ABC prime by the scale factor XY goes to x plus 1, y minus 5. And since each ordered pair is translated the same way, we're going to have similar triangles between ABC and ABC prime. Okay, now we have to see if ABC prime is similar to DE. All right, so to compare our ABC to DEF, we need to go ahead and get the ordered pairs for ABC. So for A, you have the ordered pair 2, -3. For B prime, you have 3, -3. And for C prime, you have 2, 1. And again, these are all the ordered pairs of the red triangle. And we want to compare them to the ordered pairs of DEF. So we have 4, -6 for D. For E, we have 6, -6. And for F, we have 4, -2. Okay, when you're comparing these, what do you notice? And what are the patterns you see every time? Well, if you compare the x values, to go from 2 to 4, you have to multiply by 2. From 3 to 6, multiply by 2. And lastly, to go from 2 to 4, you have to multiply by 2. And the same thing holds true on the other side. -3 times 2 is -6. -3 times 2 is -6. And -1 times 2 is -2. So we can see that to go from xy, to get from ABC to DEF, you have to multiply each x by 2 and each y by 2. Okay, and since to get from ABC to ABC prime, you're just translating, those two are similar. And to get from ABC prime to DEF, you have to multiply by a scale factor of 2. Since they're all the same, those would also be similar. So indeed, these are similar. Okay, hopefully this gives you a decent idea on how to do these couple things, and hopefully it'll give you a little assistance on your homework. See ya.